Hello everyone, I'm Sweet Balberry and welcome to my ComfyUI course series launched in collaboration with Olares. Through the previous lessons, we've already learned how to generate a variety of impressive images using different models. But if you want to express your creativity and stories even further, let's make those images move. In this session, we'll take a deep dive into the complete workflow of video generation under ComfyUI, helping you realize your own director's dream. First, we'll introduce the basic concepts and model selection. Then, we'll provide step-by-step demonstrations of key functions, including text-to-video, image-to-video, first and last frame to video, and video-to-video for different input formats, so you can turn your ideas into videos. Finally, we'll cover common optimization and post-processing techniques such as frame interpolation, video upscaling, and video extension, giving your final work a significant boost in quality and expressiveness. Before we officially begin, let's clarify several foundational concepts related to video generation. Simply put, a video is a dynamic sequence formed by playing a series of static images in order. The resolution of a video is the same as that of an image, for instance 480p, 720p, 2K, etc. Upscaling a video from a lower to a higher resolution is called video upscaling. Each single image is referred to as a frame, with the first being the first frame, and the last being the last frame. The number of frames played per second is known as FPS. To ensure optimal model performance, you should set the frame rate to match the one used during model training, typically 16 or 24 FPS. If you want a higher frame rate than the model's default, you can insert additional frames between the original frames. This is called frame interpolation. The total number of frames divided by the FPS gives you the video duration. Due to VRAM and computational constraints, most open-source generation models can currently only produce a few seconds of video. For longer videos, multiple solutions are available, such as concatenating several short video. In the simplest scenario, you generate a video using only text prompts. This is called text-to-video. If you specify a starting frame and want the model to continue from that image, it's image-to-video. Some models support both first and last frame input, with the resulting video transitioning from the initial to the final frame, known as first and last frame to video. If you already have a video and wish to reference its subject motion or depth features to create a brand new video in a similar style, you'll need video to video. Image generation models only need to denoise within a two-dimensional space about height and width, while video generation models introduce a time dimension, requiring both high-quality frames and frame-to-frame coherence, including the logical and consistent movement of objects. We won't delve too much into technical details, but you should understand this. When generating video, the model processes not just a single image per sampling round, but an entire sequence of temporal data. This significantly increases computational and VRAM requirements compared to image generation and creates an impossible triangle between render speed, video quality, and VRAM consumption. No single model can excel at all three simultaneously. Models often focus on their own advantages in different aspects. For example, the Hunyuan series emphasizes image quality, the LTXV series is known for speed, and Hunyuan Video 1.5 is designed to lower VRAM requirements. When AIGC video generation was first emerging, the hottest solution was AnimateDiff. However, it couldn't maintain good frame-to-frame coherence, resulting in videos that looked obviously AI-generated. Later, Stability AI released SVD, which is relatively simple to use and excels at subtle, natural motions, usually with smaller movements. Many solutions, such as the mouth-synced Sonic, use SVD for extension. Although Sora has not been open-sourced, its impressive and natural results, seamless camera movements, and lifelike facial expressions gave the community its first real glimpse of AI video's full potential, sparking a wave of subsequent research and open-source implementations. Today, numerous practical open-source models exist, some already capable of near-cinematic effects in specific scenarios. We believe that even more models will emerge in the future, offering better quality and generation experience. Without further ado, let's demonstrate the various functions of video generation using several real ComfyUI workflows as examples. The explanations will not be limited to specific models or workflows. Instead, the focus will be on implementation concepts and universal methods for each function, making it easier to adapt to future models and solutions.